Number 4, line L. Again, it's vectors. We haven't done it yet, but it doesn't hurt going over it. So the line L is parallel to the vector 3, 2. Find the gradient of line L. Alright, so the vector 3, 2, remember the top number tells you horizontal movement, bottom number tells you vertical. And so this means that if we started here, we've gone across 3 and up 2, and that would be our vector we're interested in there. If something's parallel to that vector, it must mean that they have the gradient of rise over run. So our rise is 2, and our run is 3. So the gradient is 2 over 3. Line passes through 0.94. Find the gradient of the line. Okay. So we know that it's a straight line. So it's going to be y equals this is going to be y equals mx plus c. We know m, so we know it's going to be y equals 2 over 3x plus c. But we now also know it goes through the 0.94, so it's going to be 4 equals 2 over 3 times 9 plus c. So this is 1, this is 3, so we've got 4 equals 6 plus c, so c is negative 2, so it's the equation y equals 2 over 3x minus 2. Okay. C, write down a vector equation for the line. Oh gosh, that's what I need. Sorry. Oh, it's a 2, not a 3. Right, okay, so we know it's parallel to this vector here, and we know it goes through this point, so that's all we need for a vector equation. So we've got r equals 9, 4, which is the point it goes through, plus, you can use any parameter, I'm going to use t, and it was 3, 2. There we go, done. Right, next one, the graph of function h passes through the point blah blah, given that h dash is 4 cos 2x find h. Alright, so we're given the derivative, we need to find the original, which means we're going to be integrating. So we need to find integral of cos. So we've got the integral of cos is sine, but obviously we've got numbers here and here, so we have to take those into account when we do this. So the 4 is going to stay there, the cos becomes sine, so it'll be sine 2x, and then we divide by the derivative of what we have here, so we're going to divide by 2, and we have plus c, so this is h. Doing some simplification, so we've got equals 2 sine 2x plus c. We now know it goes through this coordinate here, so we would say 5 equals 2 sine 2 pi over 12 plus c. 5 equals 2 sine pi over 6 plus c. Oh, okay. The big sigh was because we've got to find the value of sine pi over 6, and it's the non-calc paper. So this is where our special triangles come in. Alright, so pi over 6. Need to remember, either remember the equivalent number of degrees that is, or you remember the 2 different types of triangle. I think the easiest way, well, let's convert this to degrees. So we would multiply it by 180 over pi. These cancel. 180 over 6 is 30. So that's the 30-degree angle. So if you remember, we've got our triangle looks like this. This one is 60. This one is 30. This one is root 3. So if we're trying to find the sine of pi over 6, we're looking at the sine of this angle here. So that would be opposite over hypotenuse, so that's 1/2. So we've got 5 equals 2 times 1/2 plus c. Let me just go through that once more because I kind of said it quickly and I worry that you're not going to really follow that. So this is our angle 30 degrees, so the opposite length was 1 and the hypotenuse was 2. So that means the sine of 30 is 1/2. And we've just worked out that pi over 6 was equivalent of 30 degrees. So we know that the value is 2/2. 2 times 1/2. Because of this 2 here. Okay, hopefully that was better. So we've got 5 equals 2 lots of 1/2 is 1. So C is 4. So our final equation for hx is 2 sine 2x plus 4. Okay, it's number 6. So we've got a diagram. Okay, we can see that this is, hopefully you can see this is a cubic graph. So it's going to have something to do with x cubed. We've got 2 turning points. We've got maximum and the minimum. Okay, they've summarised where they are. On the following axis, sketch the graph of y equals f dash x. Right, we actually haven't had a lot of practice with this, mainly because they don't come up very often. Perhaps that's something that's going to change, who knows. I mean, this was 2004, so it was a while ago. My tip for you here is to, as I said, we looked at the original graph, we knew it was a cubic. We know the laws of differentiation say that we would multiply by our power and reduce our power by 1. So we know that a cubic graph will always differentiate to be a parabola. So we're going to be drawing ourselves a parabola. We then need to look for certain features of that parabola. What do we know about features of maximum and minimum points? Well, we know that's when the gradient or derivative, so f dash x, would be equal to 0. So that's going to happen at -2 and 6. So at -2 and 6, my derivative function is going to be 0. So basically, you just need to draw yourself a parabola. Oops. Things to look for as to whether it's going to be positively happy or negatively sad. We can look at the gradient here. It was quite steep. It's become less steep. Okay. But it is a positive gradient, positive gradient, positive gradient. Once you get past A, we can see that it's gone to a negative gradient. And then at B, obviously it's 0 again. And then we're going to, sorry, not as positive, positive, more positive, more positive, more positive. So that's why we know it went down and then up. Hopefully that's enough for you there. Write down the following in order from least to greatest. Okay, f of 0. Oh, f of 0. Okay, so we've got this value here. F dash 6. well, obviously that's 0. This is positive. F double dash of -2. Oh gosh. So F double dash of -2. So we can see that is a negative value, because remember the second derivative is differentiating our function here, or in other words looking at the gradient of this function. We can see that that's negative, therefore this would be our smallest, so we would write F double dash -2, then F dash 6 would be the next one because that was 0, and then F 0